when we refer to stress strain curve, where, example, we do a tensile, we understand here we got yield strength at this point. We got RE, yeah, is a yield strength or yield point. On the top here, we got UTS with the symbol RM. Okay. Now, below yield point, this we understand that area of elastic. Above yield, this is plastic. Right? Now, the area of elastic here is the area of residual stress. Below yield point here, below yield point is the elastic area, and we understand that residual stress can occur. Above yield point, area of plastic, this is what we call distortion, can occur. So distortion always occur in the plastic area above yield. Got it? Copy this one. What does it mean? If the yield lower, if you got low yield, so what happened to distortion? Higher. If we got RE yield point higher, small distortion, high residual stress. Clear about this? If we have yield lower, you got lower yield, lower residual stress. Higher yield, higher residual stress. Got it? Okay. Lower yield, lower residual stress, you got high distortion. You got high yield, high residual stress, small distortion. Clear about this? Yeah? All right, that's the things you need to memorize. Because later on question in training and exam, they are referring to RE. You got small RE, what happened to residual stress? Or maybe small RE, what happened to distortion? Okay, clear?
Repeat again, Pak.
Huh?
One more time, repeat one more time.
Oh, okay, one more time, no problem. All right. Area of elastic is area of residual stress. Clear? Area of plastic is area of distortion. All right? So we are referring to, in this case, yield. Yes. Some material got high yield. Some material got lower yield. Got it? Some material high yield. Some material lower. Like stainless steel, they have high yield. Okay? Some material like carbon steel, they lower yield. Right. Lower yield, lower RE, low residual stress. High RE, high yield, high residual stress. That's what you need to understand. Okay? It depends on the value of RE here. If you got RE lower, residual stress low. If you got RE higher, residual stress higher. Okay? Clear? All right. We move to your slide. Like what is said here. Residual stress are undesirable because they lead to distortion, they affect dimensional, and it will cause brittle, right? Or maybe hydrogen crack, residual stress. They can facilitate certain type corrosion, factor, parameter, restrain. Restrain, we understand is material not free to move, joint design, fit up, and also welding sequence. Okay. Parametric properties. So from here, we're going to look a bit detail about what factors here, right? Example, parametric properties. Please memorize this a bit. Thermal expansion, yield strength, conductivity. That's always they talk about this in your training, in your question and also answer. Thermal expansion, yield strength, thermal conductivity. That's always they like very popular. They talk. So we discuss from the question and answer here. All right. Residual stress, right? That's the question asked. It would play a major part in which of the following? If you look at certification, they are talking more to thermal stress. Where lamellar tearing is more to through thickness. Stress. Okay. Hot cracking here another name for certification cracking. Chevron cracking here is another name for hydrogen crack. And residual stress is not a factor for fatigue, and also it's not a factor for ductile. Yeah, all right. So the best answer goes to hydrogen, yes, residual, and also brittle fracture. One of the factors is residual stress. Agree with that? Okay. All right, question 2. Which of the following conditions would cause greatest amount distortion on this type of fabricated structure? Greatest amount distortion when there is no restraint. We know that restraint means material not free to move. All right? When there is no restraint, so we allow material to move during welding. So that's where the answer goes to B. Yeah? If there is highly restrained, no distortion. Yeah? All right, number 3, which combination factor will increase level of distortion? So we have talked about this. When talking about RE, low RE here, so we have RE, which is yield strength, and then we have UTS. All right, we have RE point here, and then we have RM. This is elastic. And this is plastic. So we understand area of elastic here is the area of residual stress. Area of plastic here is the area of distortion. So low RE here, when you got lower the RE, mean you got more distortion because the level RE lower, you got small residual stress but higher in distortion. Got it? If RE is lower, RE lower, so what happened? You got small residual stress, but you got high in distortion. Yeah? Clear about this? And also low thermal conductivity and high coefficient of expansion. This is what we discussed yesterday. Low thermal conductivity goes to stainless steel. High coefficient of expansion also goes to high RM, no. High yield means small distortion. All right, number 4, fabrication contain method of varying RE value. Generally, which of the following will you expect to distort the most without control method in place? You say distort the most. Look at here. Distortion the most if you got low RE, like this. Low RE, you got more distortion, less residual stress. So that's where the answer goes to B. Okay? It's related to question number 3, basically. All right, number 5. Parts of fabrication contain joint made from carbon manganese and 316L. We have discussed this about the material. So the answer goes to D because of 316L is a low thermal conductivity and also high coefficient of expansion. So this here is related to question number 3. Low thermal conductivity and high coefficient of expansion. This applies for stainless steel. Yeah. So this question number 5, 316L means stainless steel low carbon. Yeah. All right, number 6, which of the factors affecting distortion? So this one is very strict with question and answer, all options correct. 7, the fabricator approach you on the best way to reduce distortion. The joint configuration, welding, material type cannot be changed. Which of the following could be applied to reduce distortion? All right, reduce distortion by increasing restraint. That's correct. Material not free to move. Minimize amount of wear metal deposited and heavier weld bead. All right. We're going to discuss about amount of wear metal deposited, minimize, and heavier weld bead here. All right. Minimize amount of wear metal, we could compare about comparing of single U and single V. So this single U, because of volumes of the wear less, so this will be less distortion. Small, right? Minimize and the minimize amount of wear metal. comparing of single U and V. Yeah, all right. Another example. If we have multi-layer, got 1, 2, 3, 4, 5, 6 layers, and then we are comparing. Let's see that this way. We got only 3 layers. 1, 2, 1, 2, and 3. So this will be heavier. Well be. So this is heavier well be. Because you got thicker layer. This one you got smaller layer. Okay? And also here, you got more layers in this 6 layer. Here, more layers mean more expansion, contraction, and it's more distortion. This one you got only 3 layers, less expansion and contraction. So that's why you got less distortion. So in this one, you got low distortion. Okay? So that will give, that's explanation for this one. Reduce distortion by increase restraint, yes. Minimize amount of wear matter deposited, meaning we are changing from single V to single U. So single U always less distortion. And also heavier well bead mean you are reducing the numbers of layer of wear. So when you reduce layers of wear, you will reduce expansion contraction effect. You got more layers of wear, you are increasing expansion, contraction, then you got more distortion. Got it? All right. Question 8, which of the following thickness and joint configuration would you expect to produce highest amount of distortion? Okay. If you look at here, all is U, U, and U. So U compared to V, U got smaller angle. When you got smaller angle, you will reduce distortion comparing to V. Yeah, V got bigger distortion, bigger angle, then it will be more distortion in this case. How about the thickness? Remember, the thicker the material is more restrained. So you got thick material, meaning you got height restraint. When you got high restraint, low distortion. Here they ask for height amount of distortion. So that's where the answer goes to A, because you got small thickness. When you got small thickness, less restraint. Less restraint, high distortion. Clear about this? All right, number 9. After welding, it is requirement to conduct a post-weld heat treatment on certain welded joint on this weld structure. What main purpose of this? So post-weld heat treatment always reducing the stress. So that's where the answer goes to C. 10. One of your inspector asks you what would a typical PWST temperature to be applied to this fabrication. Which of the following would be correct answer when taking into account the material thickness, range state, carbon to carbon manganese steel? All right. So we understand post-weld heat treatment for carbon manganese material roughly from 600 to 650 degrees C. All right, that's the range of PWST temperature. The answer A is wrong. Why this is wrong? Because it said 50 degrees above upper critical point. Upper critical point, we're talking about roughly about 900 degrees C. If you plus another 50, so that will be 950 degrees C. So that is wrong temperature. Yeah? B, 600 to 650, that is correct. But how about C? It's approximately 100 degrees lower than lower critical limit of material state. So lower critical limit here, they are talking about 7 to 3 degrees C. So we minus 100 degrees. So that will give us 623 degrees C. So that is still range of 623, still in the range of PWST temperature. So that's why C is also correct. So the best answer goes to D. Two options correct mean B and C. Okay?